Hello everyone. In this problem, there is a family with three traits. The first trait is controlled by gene A. The second trait by gene B. And the third trait is controlled by gene D. Gene A and B are located on the chromosome number 7. And gene D is located in chromosome number 9. The table shows the number of each allele in this family. One thing we can notice is that there are three number of D asterisk allele in child number 3. That's an abnormal number, and it happened because there was a mutation when father produces sperm P. There was a dislocation of gene A or B from chromosome number 7 to chromosome number 9. In the case of mother, there was a disjoint of the chromosome. So her egg cell Q has abnormal number of chromosomes. And when P and Q were fertilized, child number 3 was born. And this means father and mother should have at least one D asterisk allele. And if we look at child number 1, in the cell of child number 1, there is an even number of A allele and odd number of B asterisk allele. That means the cell is diploid, so the child number 1 is homozygous in gene A and heterozygous in gene B and homozygous in gene D. That means a father and mother should have at least one number of A allele and D allele. So both of them are heterozygous in gene D. And from the mother cell, it doesn't have A and B asterisk allele. So the cell should have A asterisk allele and B allele. That means mother has the chromosome with A asterisk and B allele linked. Likewise, if we look at the cell of child number 2, it doesn't have A and B allele, so that means it should have the chromosome with A asterisk and B asterisk linked, and such chromosome can come from father. And from the father cell, it contains a B allele. So he is heterozygous in gene B. So when you look at child number one's genotype, chromosome with A and B asterisk allele should come from mother. And from the cell of child number 3, it doesn't have A asterisk allele. That means it's a homozygous in gene A. That means it has chromosome with A and B allele linked from father, and a chromosome with A and B asterisk allele linked from mother. But the problem is the number of B asterisk allele in child number 3 is 2. So that means she needs to have an additional B asterisk allele. And the allele come from the dislocation of a father's cell. So this chromosome with dislocation is inherited to child number 3. So that's why she has additional B asterisk allele. And the additional D asterisk allele comes from mother. When there is chromosome disseparation, additional D asterisk allele was inherited. So with this information, let's pick the right statement from the box below. So the first statement is right. The dislocated allele is B asterisk. And the second statement is not correct because although mother has the A and B allele, they are not linked. So it's not possible for her to produce egg with A and B allele together. And the third statement is right. This separation of chromosome occurred in meiosis 2. If it happened in meiosis 1, she will inherit both D and D asterisk allele. So the child number 3 would have additional D allele instead of D asterisk. So the right choice is the fourth one. And that's it for this video, and thanks for watching.